The pattern of shape that never stops revealing more details the closer you look, a structure that is so complex that it happens in the nature, mathematics, and even modern techniques. Welcome to the world of fractals. A fractal is a self-similar pattern that repeats at different scales. You have seen fractals in the nature, such as the way a tree branches out, how lightning forms, or even in galaxy or the snowflakes. But fractals aren't just beautiful; they are mathematically structures with infinite complexity. The concept of fractals was first formalized by a Polish-born French-American mathematician in the 1970s. He introduced the term of fractals to describe the self-repeating geometry structure that exists in non-integer dimensions. However, the idea of infinite self-repeating pattern exists long time ago before his work. In early mathematical exploration of this structure can be seen in the example like the countersite developed by Geo Counter in the late 19th century and the Korch curve introduced by Helger von Korch in 1904. These early fractals help mathematicians understand how a finite shape could exhibit infinite complexity. In mathematics, a fractal is a geometric shape that contains a detailed structure at arbitrary small scales, usually having a fractal dimension strictly exceeding its topological dimension. This means that fractals behave differently from ordinary geometry objects like lines, squares, or cubes. One of the most famous 3D fractals is a ninja sponge. It was first described in 1926 by the Australian mathematician while studying the concept of topological dimension. So, how do we construct a ninja sponge? What will be the process? So we first gonna start with the solid cubes, which is like the picture shows in the top right, top left. This is the level one of the sponge. And then next, we're gonna divide each face of the cubes into a 3 by 3 grid, just like rubric cube. This subdivides the cubes into 27 small cubes, just like the picture we show in the top right, but with all the center still there. And then step three, now we're gonna remove all the center cube from each face. Also remove the core cubes in the middle. This will leave us with only 20 cubes in total. And then step four, for each of the remaining cubes, we're gonna repeat exactly the same process we did early. So we're gonna divide, remove, and repeat. So the key idea is to repeat this process infinitely. With each step, the structure going to become more complex, creating a high intricate, self-repeating pattern. Despite its complexity, the Minger sponge has some strange property. It has zero volume in the limit because we're gonna keep removing the cubes in the part in the middle of the each face. Unlike regular geometry shapes, fractal has a similarity across scales and can have non-integer dimension. But what does this mean? Let me explain to you using this picture. So a line has a dimension of 1, and a square has a dimension of 2, and a cube has a dimension of 3, but fractals behave differently. A topological dimension is defined based on the connectivity, and the major sponge start as solid 3D cubes, and its Originally, topological dimension is 3. However, as we keep repeating the steps we introduced early, we will symmetrically remove the part of the cubes, increasing its complexity while reducing its volume. This will cause the sponge to behave as a axis somewhere between a plane and a solid object. As you see, the formula we use here, D is the dimension, and the formula we use to calculate the mean sponge dimension is log n divided by log s. And n is the number of the self-similar pieces after one iteration, and s is the scaling factor. And as we know, after removing the center of the cubes for each face and in the middle of the cubes, we only have 20 cubes left. So n will be equal to 20 and s is equal to 3 because we subdivide the each face into a 3 by 3 grid. So if we're doing the calculation, the dimension will equal to 2.7268. In the computer graphic, fractals are used to generate realistic landscapes, cloud, procedure, texture. Many video games use fractals to create infinite terrain with limited memory, like in Minecraft. Fractals existing in everywhere, from the microscope cell to the largest cosmic structures. Could the universe itself to be a fractal? Some physicians believe the discussion of galaxy may follow the fractal patterns. Thank you so much. If you like our videos, please